Hey guys, I'm back. I was hoping to do example 4 and 5 on the same video, but it was just taking a little too long. So I just broke it up into two videos, but it's okay. That's nothing wrong with that. We did example 4, finding the value of sine and cosine on the unit circle. We're going to do the same thing in example 5, but this time, in example 4, we found the exact value and we found the decimal approximation on the actual calculator. This time we're only going to stick with exact values of sine and cosine, which means not a big deal. It's the answer, like 1/2 instead of 0.5, or square root of 3/2 instead of 0.866, if you remember in example 4. So here we go. Start copying down what you see over here. This is example 5, page 721. We're still doing the same thing. We're finding the exact values of sine and cosine on the unit circle. We want to find the exact values of the cosine of negative 120 degrees and the sine of negative 120 degrees. Remember, if it's a negative angle, if theta, remember theta is the angle that has this symbol. It's a Greek symbol. And it's just used, it's like a variable, x, but except they use it for angles. And it's pronounced theta. Greek symbol theta. So if it's negative 120, remember, negative 120 means you're going to go to the right 120s clockwise. Clockwise is negative angles, and counterclockwise has positive angles. So I went ahead and I drew, step 1, sketch negative 120 degree angle on the unit circle. Remember, unit circle, the origin is at 0, 0, and the radius of the circle is 1, always. And then the initial side of the angle is the positive x-axis. The terminal side is the end side of the angle. And like I said before, the x-coordinate of the point on the terminal side of this angle, 120 degrees, remember this is negative 90, it would be negative 90, and 30 more would be negative 120. This angle here is 30 degrees. That's important to know because we're going to draw a right triangle. Okay, and then the point on the unit circle on the terminal side of the angle is the answer to the sine and cosine. The x-coordinate being the cosine of negative 120, and the y-coordinate of this point being the sine of negative 120 degrees. So I'm going to draw a 30, 60, 90 triangle again, a 90 degree angle here. Do you see the triangle I drew? Again, there's more than one way to draw this triangle. The horizontal length is going to be the x-coordinate. The vertical length is going to be the y-coordinate of this point. That's gonna help me find the sine and cosine of negative 120 degrees. So let me go ahead and do that now. Let me draw the 30, 60, 90 to know what's what. Remember, what's this side here? This is the hypotenuse. Well, it's also the radius of this circle, isn't it? Here's the center of the circle. Here's the outer edge of the circle. That's going to equal 1. The radius is 1. It's a unit circle. Knowing that, now do we know what this side, the short leg, has to be what? Remember? Well, it's going to be 1/2. Isn't that the x-coordinate? Isn't that the horizontal length, the x-coordinate? So the x-coordinate of this point is 1/2. What's the y-coordinate? Well, this is the short leg is 1/2. How do you find the long leg? Isn't it related by the square root of 3? Don't you gotta, because it got longer, you gotta multiply by the square root of 3? If I was given the long leg and I was trying to find the short leg, I would have to divide by the square root of 3. But right now, I'm given the short leg is 1/2. Trying to find the long leg, I got to multiply by the square root of 3. And we already did that before. It's a square root of 3/2. That's the y-coordinate. Why is it the y-coordinate? Because it's the vertical length of this triangle. The horizontal length is the x-coordinate. The vertical length is the y-coordinate. Isn't this cosine of theta? Isn't this going to be the sine of theta? Perfect. Now that I have that, I got my answers. So the cosine of negative 120 degrees, well, that's going to be the x-coordinate of this point. The x-coordinate is 1/2. Is it negative or positive? I went to the left. It's negative 1/2, isn't it? Because aren't I going to the left, negative 1/2, and then down? And then the sine of negative 120 degrees is going to be the y-coordinate of this point. It's square root of 3/2. Well, wait a minute. I went down. Isn't it going down on the x and y coordinate negative? These are my exact answers. Negative 1/2, negative square root of 3 over 2. Let's check and see if this is what we get, because on the calculator, you're not going to get the exact answers, but you will get a decimal answer. We know that negative 1/2 is negative 0.5. We know that negative square root of 3 over 2 from the last video was negative 0.866, so on and so forth. Remember that? We're just using that to check. The real answers are going to be, the exact answers are negative 1/2 and negative square root of 3 over 2. Those are the exact answers. Let me just check them, make sure. Remember, we're talking about degrees here. We didn't talk about radians yet. We'll talk about radians later on. But we're talking about degrees right now. So make sure your calculator is in degree mode. If you don't have a scientific calculator, if you don't have a regular calculator, a graphing calculator, you can still use a scientific calculator, but make sure you know where the degree and radian things are. Right now, it's still in degree mode, so I'm good. Not in radian mode. So now let me go, quit. Let me go and find the cosine of negative 120. Cosine of negative 120 degrees. I put minus 120. It's going to be negative. That's why it's an error. So try that again. This is negative. See the difference between minus sign and negative? That's why I got an error. You got to use the negative sign at the bottom, not the minus sign. Makes a big difference, obviously. So look what happened. I used the minus sign, I got an error. If I use a negative sign, 120, I will not get an error. I'm going to get negative 0.5. Good, we were right. Okay, now the sine of negative 120, let's see if you get negative 0.86, which is really the same thing as negative square root of 3 over 2. We should get negative 0.866, whatever, irrational answer. So sine of negative 120 degrees is equal to, negative 0.866025, whatever, irrational answer. But we want the exact answers, so the exact answers are negative 1/2, negative square root of 3 over 2. Now what I want you to do is, again, look what I did. I just showed the work here. One way of drawing the triangle would have been right here, right? Here's another way to draw the same triangle. Look what I did here. So I drew the triangle, instead of drawing it on the inside of this, I drew it on the outside. It's not the same thing. If this is 120, then this is going to be 180. What's left over? Isn't that 60? This will be 60 degrees. This will be 30. This is the long leg. This is the short leg. It's the same thing. I could have drawn the triangle in here or out here. I'm telling you that you can do it either way. You get the same answer. Here's the point again, same thing. This is 1 because it's the hypotenuse. The radius of the circle is the same as the hypotenuse, opposite the right angle. 1/2 is going to be the short leg because it's half the hypotenuse. Well, 1/2. The x-coordinate is 1/2. The y-coordinate is the long leg. Square root of 3 over 2 times a half. Square root of 3 times a half is the square root of 3 over 2. Same thing. So you could do it, draw the triangle inside here, or you could draw the triangle on the outside here. The horizontal distance is still a half. That's going to be the x-coordinate. The vertical distance here, or the long leg, is going to be square root of 3 over 2. That's going to be the y-coordinate. Again, vertical distance is the y-coordinate and then the horizontal distance is the x-coordinate. Now, what I want you to do is, I want you to do quick check number 5, A, B, and C. Here it says compare the square root of 3, cosine of negative 120 and sine of negative 120 answers with the calculator. I already did that for you, but you could do that again. B says find the exact values of square root of, cosine of 135 and sine of 135. So you got to do a 135 degrees. This time you got to go to the left. 135 is 90 plus 45. That's going to be right here down the middle. That's going to create a 45, 45, 90 right triangle. Remember that the relationship here is the square root of 2. Remember that. Okay, and here is cosine of 150. Well, cosine of 150 is positive, so you go to the left. 150 is 90. 90 plus what is 150? 60 more. So you're going to create a 30, 60, 90 triangle here to figure out the x and y coordinates of the point on the terminal side. And then that's going to help you figure out what cosine of 150 is and the sine of 150 is. And you can check your answers on the calculator, but they won't be exact answers. They'll be decimal answers. Now, when you're finished with all that, I have a homework assignment, page 722. Do 1 through 28 all. Again, this covers examples 1, 2, 3, 4, and 5 of section 13-2. And there will be a quiz on 13-2 by itself. So do the homework. Make sure you know how to do it. Do the best you can. And have a great one. I will be uploading this video also. Again, example 4 is a video. Example 5 is a video. I ended up doing section 13-2 3 different videos. Example 1 and 2 was one video. Example 3 was a video by itself. Example 4 was a video by itself. And example 5 is a video by, actually 4 videos to do 13-2. And this is the 4th video. Thank you guys. See ya.